Hey, geometry students, happy Monday or Tuesday, whatever day you're watching this. We're going to cover homework 4.2 on angle relationships. And so we've got a number of definitions here, and they're just going to be really important because they allow you to solve for the angles within triangles by knowing these special relationships. So they're not exactly terms to know, but they're special circumstances to be aware of. So let's jump right in. The first definition for 4.2 angle relationships is the triangle sum theorem. And again, you can see I'm abbreviating this triangle sum theorem. And that is that the sum of a triangle's angles are 180 degrees. So just as simple and straightforward as that, any triangle of any shape, if you add up, so if we have triangle A, B, and C, if you add up the angles, and so angle A plus angle B plus angle C is going to equal 180 degrees. Okay, no matter what the shape is. It's not when they add up to 180 degrees, like complementary or supplementary or something. It's any triangle of any shape will always add up to 180. And so if you know two of the angles within a triangle, then you can immediately know the third one. So like as another little example here, say I have a triangle, looks something like that. And if I know this angle up here is 30, and I know this angle down here is 70, okay? And so you can see, well, that's 30 plus 70 is 100, then you can know immediately that this third angle here would have to be what would make it add up to 180. So that would then, of course, have to be 80 degrees, okay? So just a key basic thing that you're going to want to know backwards and forwards is that the three angles within any triangle will always add up to 180 degrees, okay? So let's move on from that because then the next two are actually based upon that idea. If all the angles within a triangle add up to 180 degrees, then we have what's called the right triangle corollary, which means that the acute angles of a right triangle must be complementary. So let's take a look at this. What does that mean? Well, it means that if I draw a right triangle, so this has to do with right triangles, and I know that the three angles add up to 180 degrees, well, first of all, I've got 90 degrees right here. So what that means is you only have another, for it to add up to 180, you only have another 90 degrees split between this angle here and the other acute angle here. That's what it means by the acute angles. It's talking about the non-right angle, the non-90 degrees. So when you have a right triangle, you don't have to even worry about everything adding up to 180. You can just know the two non-right angles have to add up to 90 degrees. So again, for example, if you had a right triangle, and they tell you this is right, and then they tell you that this up here is 30 degrees, then you know that the other angle down here must be complementary, must add up to, we could put a little note there, 90 degrees. And so that means this other angle, just looking at this, would have to be 60 degrees, because 60 plus 30 is 90. Okay, because your other 90 is always taken up by that right angle. So that's the right triangle corollary. Then we have the equiangular corollary. Because all the angles within a triangle add up to 180 degrees, then that means all the angles of an equiangular triangle, oops, I should put that in there, equiangular triangle are 60 degrees. Because if you have a triangle that's all equal angles, so this and this and this, you know that they have to all add up to 60, I'm sorry, 180, and so there's only one possible answer. Because 180 divided by 3 is your 60 degrees. Okay, so these have to all be 60 degrees. There's no other way to have a triangle whose angles are all the same measurement because it's a fixed total. They have to add up to 180. In class, we're going to talk about why that is the case. We can demonstrate it. Okay, so the corollary is just that equiangular corollary is just knowing that if you have an equiangular triangle, you immediately know all three angles. They don't have to give you one or two. Okay, and then we have this thing called the exterior angle theorem. And this is a little break from the previous three. And it says that the measure of an exterior angle is equal to the sum of the remote interior angles. All right, that's a mouthful. So let's demonstrate it with a picture. So I always want a picture with these. And so first of all, let's talk about what an exterior angle is. An exterior angle is an angle formed that if you extend one line of the triangle, beyond its vertex. So this right here is what we call an exterior angle. And I made it there, but I could make another one right here by extending this if I wanted to. This would also be an exterior angle, okay? So that's what we mean by exterior angles. And you can create one on any one of the three corners of a triangle. And so what the exterior angle says is that if I have a triangle, I'll draw another example. So and I create this. It basically means that if I'm going to call this angle, I'll call this angle 3. And then I have angles 1 and 2 here. That is where 3 is an exterior angle, and 1 and 2 are the remote interior angles, okay? And what we mean by remote is they're not the angle right next to the exterior angle. So it's not this one right here, okay? That's the adjacent angle. We're talking about the remote ones. And what this simply says is that you know that angle 1 plus angle 2 is equal to angle 3. Okay, the exterior angle is always going to be equal to the sum or the adding up of the other two angles opposite from it. Okay, so that's what this theorem states. So if I know what angle 1 and 2 are, I can add them together and I can know what 3 is. Or if I know what angle 1 and 3 are, I can subtract 1 from angle 3, and that would have to equal angle 2. Okay, and I mean, we can kind of explore this for various reasons, but I won't get into it in this video. It has to do with 3 and the third missing angle, but I'm just going to keep it at the definition. We'll talk about it in class. So that's the exterior angle theorem. An exterior angle is always equal to the sum of the opposite or remote interior angles. And finally, we have the third angle theorem. And again, this is just a pretty basic idea. And it says that if two angles of two triangles are congruent, then the third pair of angles are congruent. So say we have two triangles like this, and I'll go ahead and label them A, B, C, and D, let's do it over here, D, E, F. And this is saying if you have two triangles and you know that, I'm going to do this in blue, we know that angle A is congruent to angle D, and I know that angle B is congruent to angle E, then I know that angle C must be congruent to angle F. And that, again, is linked to the idea that they have to add up to 180. So if A and D are the same and B and E are the same, in other words, if I know A and B, C only has one option. And if E and D are the same as A and B, then F only has one option, and it's the same option as C. So the third angle theorem just says if you know two sets of congruent angles and triangles, you know that that third set has to also be congruent. And again, we could see this if this is, let's just use our simple, if this is 30 and this is 70, right? Then that means C would have to be, that's 100. So I'm picking easy numbers for our example. C would have to be 80 degrees, okay, because that adds up to 180. Well, if A is congruent to D, then D is also 30, and E is equal to B, so that would also have to be 70. So there's no other way F would have to also be 80 degrees, and therefore congruent to C. So it's always going to be the case, and so that's what we call the third angle theorem. All right, so that's our definitions. All angles add up to 180. The two acute angles of a right triangle are complementary or add up to 90. All the angles in an equal angular triangle are 60 degrees. And the exterior angle of a triangle adds up to the sum of the two interior remote angles. That maybe is the biggest mouthful of all of them. And then the fact that if two sets of angles are congruent, the third set must also be congruent. So let's take a look at 4 just practice questions. So number 4 says we have to solve for a y. And it gives all this cool space application, but it's just a triangle. And so we have 3 values, or we have algebraic expressions for the 3 angles of the triangle. We have to find y. So we must be able to write an equation. All right, well, what's the relationship between these 3 angles? Well, we know that they all add up to something. They all add up to 180. All right, so that means my equation can be taking all 3 angles and say that, so 3y plus 13 plus 5y minus 5 plus the third angle, 2y plus 2, equals 180 degrees. All righty. It's a simple equation. They're looks kind of long, but again, that's just saying, okay, I know that triangle sum theorem states that all angles equal 180. So now let's Let's go ahead and just solve it. First, simplify. I'm going to add up all my y's, and I'm going to add up all my constants. They're distinguishing them from one another. So I have 3y plus 5y, which is 8, plus 2 more y, which is 10y. So I have 10 y's. Then I have 13 minus 5, which is 8. Always a tricky one. And then 8 plus 2 is 10. Okay, so that means 10y plus 10, and then equals 180. Now we can just do our basic algebra. To get y by itself, I'm going to subtract 10. Cancels out. So we get 10y equals 170. Then to get y by itself, I'm going to divide by 10. And so that just gets me y equals 17. And it doesn't, I don't have to find the angles because I could plug it back in, but the problem simply says, that would be if you did number 5, which you'll do probably on the exercises. But for now, plug it in. So my y is equal to 17. Bada bing, bada boom. So a lot of this lesson, you're going to be writing equations to solve for variables, and you want to know the angle relationships and the definitions in order to set up the right equations. Let's look at number 6. Number 6 is an application of the right triangle corollary. It describes a right triangle, and it says that one of the angles is 20.8 degrees. All right, well, what we learned is 90 degrees of my triangle is taken up right here. So that means that what's left over for these two angles is another 90 degrees because they have to add up to 180. And so that means this angle here is the difference between 90 and 20.8. So I could think of this as two ways. Algebraically, I could think of it as, well, 20.8 plus the missing angle equals 90. Okay? Or you could just think of it as 90 minus 20.8. And that's how we would solve this. I would subtract 20.8 from both sides. And that just means x is equal to, let's see, what is that? That would be 69.2 degrees. It's an angle measurement, so let's not leave it naked. 69.2 degrees. Okay? So because they're complementary. So again, these two acute angles should always add up to 90. And last one, number 10. So number 10, here we go. Number 10 is going to be similar. It says just find the measurement of each angle. And number 10 asks for, we need to find the measurement of angle L. So we're looking for this one down here. Well, first thing we notice, do I know all my angles? This is 90. So that means this is a linear pair. So that means this is also 90. So this is just like number 6. This is a right triangle. So what does that mean? It means that these two, K and L, must be complementary or must add up to 90 degrees. So here I can get an equation. It's going to be slightly different than number 6, but I know that K plus L equals 90. I don't have to write it this slowly, but I will. Angle K plus angle L equals 90 degrees. And of course, angle K is 7x. So 7x plus 6x minus 1 equals 90 degrees. And let's go ahead and start solving. 7x plus 6x is 13x, so we'll simplify. Minus 1 equals 90 degrees. Let's go ahead and add our 1. So we get 13x equals 91. Get x by itself, we're going to divide by 13. And so we get x, 91 divided by 13 is x equals 7. Alrighty, so there's my x equals 7. And so if I check what they're asking me to find, it's not just the measurement of x. I'll be done in just a minute. Measurement of x, but I need to find measurement of angle L. So that means I need to take my x and I need to plug it back into the expression there on angle L. So let's just plug it in and we will be done. 6 times 7 minus, not equals, minus 1. So that's going to be 42 minus 1, and that leaves me with 41 degrees. Alrighty, and that's what they asked us for, and that is correct. Box my final answer, so 41 degrees. So again, we used the right triangle corollary to know that K plus L has to equal 90. We plug in the expressions, we solve it algebraically, and in this case, we needed to plug X back in order to find the actual angle measurement. And if we wanted to, we could very easily figure out what angle K is, because it would be 90 minus 41, okay, which I believe is 49. Alrighty, hope that helps. We'll be working on this in class tomorrow. I welcome your questions, and we'll help you however I can. All right, good luck with the quizzes. See you soon.